Hi, my name is Michelle Trott, Scientific Content Manager at Izon Science. Today I will be discussing 5 aspects of tunable resistive pulse sensing that make it such a precise technique for nanoparticle analysis. Firstly, TRPS provides information on a single particle level. When samples are measured using TRPS, each particle is characterized only once as it passes through the nanopore. Once a particle has passed through the nanopore, it is not measured again, enabling true single particle measurements. In contrast, bulk methods known as ensemble techniques measure many particles at the same time. With some ensemble light scattering techniques, high molecular weight particles will disproportionately scatter light, despite their relatively low concentration in the sample. This leads to a disproportionate amount of information, contributing to the overall ensemble averaged measurement and a distortion of particle size distribution. The single particle nature of TRPS has implications for the resolution that can be obtained, as shown in the figure. Here, the size distribution of a quadrumodal sample was analysed using TRPS, NTA and DLS. The ability of TRPS to resolve the 4 subpopulations is clearly shown, contrasting with the lower resolution results produced by NTA and particularly DLS. TRPS measurements utilise linear relationships between blockade and particle characteristics to determine size, concentration and zeta potential. Size measurements are made possible by the directly proportional relationship that exists between the measured blockade signal and particle volume. Concentration insights depend on measuring blockade frequency, which is directly proportional to the sample concentration. And there is a linear relationship between measured electrokinetic particle velocities and zeta potential. Together, these relationships provide a consistent and solid basis for the measurement of particle characteristics. Meanwhile, the ability to test a blank buffer provides confidence. When the solution is devoid of particles, there should be no blockades showing against the background current. This screenshot shows the signal trace when running a measurement electrolyte through the nanopore. As there are no particles in the measurement electrolyte, no blockades are present. Whereas contaminants would not be detected with ensemble instruments, TRPS will detect the presence of individual particles in the solution. This allows you to proceed with confidence, knowing that blockades are truly representative of particles in the sample. As information on size, concentration and zeta potential are all derived from interpreting information from these blockades, this is very important. TRPS measurements require the use of standards, which are analysed under the exact same conditions as the sample. Izon supplied calibration particles are negatively charged carboxylated polystyrene particles, or CPCs, which have been previously characterised against neutral NIST particles. CPC measurements are used in calculations of sample characteristics and allow all measurements to be fully traced back to a NIST standard. And finally, the Exoid software provides a real-time measure of the root mean square, or RMS, which is a strong indicator of the signal-to-noise ratio. As the RMS value is constantly being updated, parameters can be adjusted until an acceptable RMS value of lower than 15 picoamps has been obtained. Specifically, this involves tweaking stretch, pressure and voltage prior to TRPS calibration and sample measurements to ensure that the background noise is at an acceptable level and that the blockade size is large enough compared to the background current. If the recommended RMS is exceeded, you can pause the measurement, regain a stable baseline and then continue. This may require some effort, but it does ensure that measurements are only taken when all of the conditions are correct. In summary, tunable resistive pulse sensing is unique in that it is a true single particle technique, and measurements of physical characteristics are based on information obtained directly from the blockades. The ability to test a blank buffer and use standardized calibration particles provides confidence. Unlike other techniques, which will give you a reading under any conditions, TRPS requires you to optimize and maintain correct conditions throughout calibration and sample measurement. I hope that was helpful and appreciate you taking the time to watch today. To learn more about these factors and others that contribute to the precision of TRPS, Be sure to visit Izon's website and read more in the article linked here.